Okay, good evening, all of you. So we'll continue with the problems related to the springs one only, that one. So today, like a morning, what we discussed about the springs one, the similar ideas is what happened. We are going to carry forward here, and we'll focus more on the application part. That one. Already now we know basics. What are the basics like? Spring elongated, the spring force will act towards center at both ends. If spring is compressed, the spring force will act at both ends away from the center, and the strain at any part. Strain of one part in a string is equal to strain at other part. There's another thing. Then spring force is elastic force. And what is the spring force equal to? K into X, K into X, that one. Spring constant into the elongation or compression of the spring. Then what is that here? K is a spring constant. It depends upon the Young's modulus, the elastic constant of material, area of constant of material, and the natural length of the spring. So like this, we defined the spring constant also. Okay, let's, I'm giving now to the 3 segments cut from a long elastic cord. So I think all are made up of same material. So you look at the 3 segments cut from a long elastic cord. So all are made up of same material. So here, this should be. Okay, look at now. So these are the, the 3 segments are there. So the angle between them, theta, it is also given for that. What do you expect the length? And you see this part of the sentence. If the extensions in the cord are negligible as compared to their relaxed lengths. Actually, what is the state of these two? And here a block is suspended.
Sir, can you remove the highlighting, sir?
Oh, it came something happened. Yeah, fine. Here is a particle is suspended. Now look at the, if extension the cords are negligible as compared to their relaxed lengths. On this, I think this sentence, we'll see what happened. Yeah. Oh. Okay, this sentence is the core part of the problem, the idea of the problem. So what is the state of them? What is the state of this particular cord or elastic strings now? They are being elongated, no? Though they are elongated, but still what happened? That extension is negligible compared to their length. Fine, there's the thing. So what do you expect the length of them? Will all 3 will have same length or different length? So there are strings will give numbering for them. There's a 1, 2, and 3. Look at 1 and 3. They should have same length. And look at the 2. It should have different length. So let me give the number. This is 2, 1, and 3. Look at the 1, 9, 2. Or so 2 and 3 will have same length. So the length of them are different. So I'll first, this is the one equation, I'll write it. So that I'll be on safer side. So let L2, let this be L1. This is theta. So what is the equation now? Cos theta equal to L1 by L2. This is the idea of the problem. Lack of this, without this information, no way we can reach the end answer. Okay, there's a thing. Then the tension. So we'll calculate the tension. So here is the spring force will be acting. Call that as F2. Here F1 and this F3. As 2 and 3 are identical. So next, what is the condition? F2 is equal to, in fact, F3. because 2 and 3 are identical, no? What about elongation? Can you say about the elongation? All three will have same elongation? No, it's need not this one. So the elongation, I'll show the elongation the strings by red color strip. Huh? So compare the elongation. This will have elongation this much. And what about the elongation? Elongation here will be what is that green color, red color? That is the elongation, and that elongation is small compared to their length. I'm dropping further the perpendiculars also.
Sir,
Yeah.
sir, when they are cut in equal manner. Sir. Are they cut in 3 equal parts?
He didn't say 3 segments cut from a long elastic light cord are knotted at point P. The other ends of cords are attached to ceiling. He didn't say that equal parts, no. 3 equal segments cut. No, he just said segments. Fine. The
Okay.
sentence.
Things are negligible, right? So
Draw one more triangle. So that the same thing. So that will be easy for you. If you can get this much, I think problem is over. It's very easy. You can see that. No.
Sir.
sir,
I'll take out the video. Some problem is there.
Sir.
Yeah.
Sir, why is the elongation in the second and the third segment perpendicular? Why is that angle?
So I'm taking that one. So here what happened? See, like when the block the moment I release, no. So what happened? The strings what happened? The elastic cord they'll elongate. So here what happened? I'm dropping a perpendicular here to get the relation between them.
sir, how did you tell that the elongations are like that? I mean,
No, you look at that the diagram given. No, you look at the theta, the diagram. They're making an angle theta. So definitely what happened? The elongations will be different. And the relationship between them, I'm showing it here.
okay, sir,
Sir.
will be different. But how did you drop a perpendicular exactly at the
I'm
end of elongation and all?
This one, you see that. So you mean to say why that triangle, right angle triangle?
Yes, sir.
Okay, that one. So let's come from here. So look at the, uh, what is the, all are of made up of same material, no? All are of same material. Then how the spring force and the elongation are related? Directly proportional. The spring force and the elongation are directly proportional. Okay, clear this one. So the elongation of both the strings solvent depends upon the length also, because spring force depends upon the length. So look at the initial length of the cord. They are different, no? This one. The initial length of the cord are different. So therefore, though what happens, they're made up of same material, because of the different length, they will have different spring constant. And the spring force is proportional to what? The elongation. So based on that, what happens? So we are assuming that the elongations must be different here. So I'm just projecting it, that one. You can see that. So here actually, the moment I release it, both will elongate. So here it will be like this. Initially, let's say that they are relaxed here. So when I put when I suspend a particle, so what happens? The springs will come like this. This will be the situation. You're supposed to, you didn't you not bother to analyze the problem. They're just looking at some mathematics here. This was the initial portion of the strings, no? So when I suspend a mass, what happened? It will descend. Got this? So if you look at the length now, so this was the thing, no? Are you getting the idea now? Okay, got this. This will be, so this was the position, no? So here, how much it got elongated? This much is what the elongation x2. This is what x1. Okay, it's not that to get the answer, I'm assuming the practically this what happens here.
So then the angle also changes, right?
But what he said, extensions are very small, no? I think you should, like I highlighted that particular word, not
Okay, sir.
analyzing. Huh? Not analyzing, you have to look at really the English part, very, very important here. So F1, so F3 equal to F2, no? So therefore F1 plus 2F2 cos theta should be equal to mg. So there's a one equation. We have this one. So let's come for, all are made up of same material. So they will have same Young's modulus. So then we'll try to write some relationship. This elastic constant, it is related to F1 by A, elongation in this X1 by L1. Similarly, F2 by A. Now there's the one formula related to Young's modulus and the force and this one. So as Hooke's law, what it says, stress directly proportional to strain. So what is this X1 by L1? X1 is elongation, L1 was length. So this will become strain. What is F1 by A? Will become stress. Stress directly proportional to strain. If I remove that, I'll get the elastic constant that I'll call Young's modulus. So how that stress and strain are related? By this equation. So as all three are made up of same material, so therefore all will have same elastic constant. So now from this, F1 L1 by X1 equal to F2 L2 by X2. Okay, let's replace F1 and F2, some relationship what we have here. So what we have to calculate, find the tensile force T developed in the middle chord. We have to calculate F1. We have to calculate F1. So here F1 by L1, L2 equal to X2 by X1 equal to F. So what is X2 by X1 will become cos theta. F1 L1 by L2 cos theta equal to F2. This value And then any relationship, this one, cos theta, L1 by L2, what we can write? L1 by L2 is cos theta. So therefore, the next equation will be cos theta. This is cos theta, F2. So what is F2 equal to? F1 cos square theta. That will substitute here. F1 plus 2. F2 will be F1 cos square theta. This is cos theta. So what is F1 is equal to? Mg by 1 plus 2 cos cube theta. Okay, this will be what is asked here. Just this diagram is very important. This is what I actually have to come from here. Okay, I'll come to this one. So let me.
Sir,
Yeah.
I have a doubt, sir. Sir, when we pull a thread or something, then
Please do think. I explained enough ideas. I don't think so. What I gave is not something 50%. The maximum information you are supposed to analyze it.
sir, no, sir. I mean, the area of cross section also changes, right?
No, that is nothing that one. The area of cross section will change only when they give Poisson's ratio. Okay, fine. If at all, if it is there, they'll mention that condition.
Okay, sir.
Okay, let me introduce to the string signed when it is cut, that one. That is something very important. You have plenty of numericals based on this. So once after getting this, we'll go back to the previous problems. So find the acceleration of blocks momentum just after string is cut at point A. The system is in equilibrium initially. The system is in equilibrium. Okay, now for first, what are the forces that are acting? What are the forces are acting? M1G. And what is the state? The spring. So spring will get elongated. So write Kx, write Kx, and this is M2G. And here the tension, let it be T. So the initial, let's first show all the things now. So here how much it will be? M3G. Here also some tension will act. We are, okay, let it be T naught. Okay, now what's happened? I'm going to cut the string at A. There's nothing, just it's a logical problem, nothing to do, no concept, nothing. Just you have to stick on to again the very small basics ideas of the spring. This is M2. This is M1. And this particular string is cut, no? So what will happen to string? So look at the string, how I'm showing it. And this will be there as it is. You have to draw two diagrams, huh? Then only it'll be very easy for you. Without diagram, by seeing, I think you should not do anything. Now what will happen to the thing? So pulley is light. You feel very interesting such problems I'll discuss. You definitely feel like, okay, sir, like once if I do 2-3 problems, no, you feel as you can manage very comfortably. Just the basic idea, you must have clarity here. No. What will happen to spring force? Let's come to one by one. First, what will happen to this string? At point it is being cut, no? At point it is being cut. What will happen to this black color string? There are two strings are there. Are you looking at? red color string and a black color string. So which color string is cut? The black color string is cut. The spring, okay, spring is not cut. Okay, this is the thing. Okay, let's come for this kx. What is kx equal to? Kx equal to m1g. Then what was the earlier tension? The earlier tension was kx plus m2g. So write all this one. So so now this t equal to m3g plus t naught. These are the initial things. You identify all this one. Okay, now come for this. What will happen to spring? What will happen to spring force? If this string is cut, the tension, this will become loose, no? Earlier this was taut. This string was taut. Now what will happen to this string now? It will become loose. Now go back to the string. If the string become loose, what will be the tension in that? Will become 0, no? Fine. So what will happen to weight? As usual, the weight continue to act. Now what will happen to spring force? This was the first question I'm asking you. Spring force will not change. The reason for that, the moment you cut, so just after. So what do you mean by just after? Again, this word, the meaning, English language, what you should interpret. Just after. The moment I cut string, then and then only. The moment I cut the string, I'm discussing problem, not after some time. Got the idea? Just after string is cut at point A. The moment I cut, I'm discussing the problem. The moment I cut the string, at that instant only, I'm discussing the problem. Tell me what happened to spring force, M2 and M1. They'll not undergo displacement at that instant. They were at rest. So what is the state of M2, M1, M3? They were at rest, no? So what will happen? The inertia of rest will be there. I'm asking you to go back to all the basics here. So what is the state of M1, M2, M3? What is the state of M1, M2, M3? They are at rest. So the moment you cut this string at point A, so what happened to M2 and M1? They will try to retain that inertia of rest, but the forces acting. So what happens? They'll accelerate from rest. This is what happens here. So what will happen to spring force? Spring force will not change. Now you have to ask me really, sir, why spring force will not change? So what is the state of M2 and M1? They were at rest, no? They were at rest. The moment you cut the string, what happened? From rest, they'll accelerate, no? From rest, they'll accelerate. So from the rest, they'll accelerate means, so still what is M2 and M1? So you can put almost like they're from rest, they'll start accelerating. So what will happen to spring, the ends of the spring? They'll not undergo displacement at that instant, the moment I cut it. So what will happen to if the ends of the spring does not undergo any displacement at that instant? If there is no change in the displacement of ends of the spring. So what will happen to spring force? No change in spring force. The same spring force will act. So what was the earlier force acting on the block M1, M1G and KX? Now also KX and M1G. So what will happen to block M1? Will be at rest. Able to interpret this. So really the laws of motion is what we are trying to conclude here now. Now come for M2. I want block M2. So what is the force acting? M2G plus Kx, no? M2G plus Kx. So the acceleration of block M2 should be equal to, A2 should be equal to Kx plus M2G by M2. So what is the value of Kx from here? Kx equal to M1G. So this will be M1, M2. So this is the acceleration. What direction this acceleration? Downward. So the acceleration of block will be like this. What about M3? Anybody?
G, sir.
G, sir.
G, sir.
What about this tension T naught here?
That, sir.
Sudden change in tension possible. A sudden change in spring force not possible under this given circumstance. So instead of drawing like this, so this particular string, what happened should be the moment you cut it, it will also be like this because the M3 starts moving. The tension what happened, suddenly what happened? Here, you can ask question, sir, are you sure it should be like this only? Tension is set up by pull or push forces?
Pull, sir.
By pull forces, no? So tell me like and all M3G will act downward. So what force is set up now? The push force is set up. So what happened to string? String will become loose the very moment. So what is the only force acting on the block M3 now? Its weight. So therefore, what is the acceleration of block M3? Should be equal to these are the best problems for students to really make observation. So acceleration of the block equal to M3G by M3, which is equal to G downward. So so many ideas I'm introducing here. So many ideas are brought here. Are you just do make observation? So many ideas are there. So why this you made loose? The tension is set up by what? The pull forces. So here M3G is what? It's like a push force. So what happened? The very moment you cut the string A, what happened? This will become loose. So then only weight of the block M3G is acting. So as it will accelerate. Got it?
Sir,
Yeah.
sir, when A2 starts acting, sir, on mass 2,
Yeah. Okay, fine.
kx will become in the opposite direction, right, sir?
Which one? Which one? KX, huh?
Eventually.
Oh, no. I think you have seen elastic band. Have you come across elastic body? I am asking very general thing. So what is the state of this? Elongated. Then for it to become, say like a kx to act upward, what should happen to spring? Spring should undergo compression, no? So is it possible? So when do the spring will first what will happen? As the very after some time, after cutting the string at point A, what happened? Now the M2 starts moving down. Then M1 is also acting. Clear this. Next possibility is what? Then the elongation may decrease. Got the idea?
Yes, sir. I mean,
Then
it
the
can.
location.
There
But
is eventually it can be compression, right?
what is a thing you are not you are thinking, but what happened far away from the physics, basics of physics. Elastic band is there, it's elongated. For it to become compressed, tell me what should happen. I'm nothing big I'm asking. This is the elongated. For it to become compressed, this is the natural length. Tell me like from elongation to come to compression. Tell me what all should occur. I think enough of common sense is needed here. Suddenly from elongation will become compression. No, what should happen? The elongation should decrease, should attain natural length. Then it should undergo compression. Will agree? So everything occurs, such a thing occurs. It's like we are discussing that instant, no? Just after. What do you mean by just after? I think the word just after could not, still most of you are not getting. What do you mean by just after?
Just after the moment we cut the string, the moment
you cut string, we are discussing problem. Tell me like what will happen to spring? Suddenly from elongation will it become compression, elastic band.
I never did that, sir.
It needs some time, no?
Yes, sir.
Okay, fine. So kx should not be, I should not show upward. Sudden elongation, from elongation, sudden compressions, from compression to sudden elongation, not possible. I think there's one trick is what if you can accept, no? You finish or you can manage any of these questions here. Sudden change in tension, possible. Sudden change in spring force means suddenly from elongation, suddenly compression, not possible. Compression, suddenly elongation, not possible.
Sir, in car wheels.
Yeah. SS, somebody?
Sir, what happens in car's wheel?
What happens in?
Car's wheels.
I'm not getting what you are
Wheels
saying.
of a car. Sir, when a speed breaker comes in the wheels of a car.
Okay.
Suspensions, sir.
So suspensions are there? No, there also sudden elongation compression will not occur. No, it will gradually, because of the viscous drag or everything, what will happen there? The gradually what happen, the you can say the oscillations are damped. Got it?
Yes, sir.
But suddenly from elongation will not become compression. That much I can say still there also. Okay, let's go for next one. Read the question. Just these are the first, no, as we proceed to. Oh. I think you are able to hear me.
Yes, sir.
Yes, sir.
We are able to hear you.
Yeah, come for this. Can you hear me clearly?
Yes, sir.
Yes, sir, we can hear you, sir.
That one, yeah. Screen visible, huh? Some problem came.
No, sir. No, sir.
Nothing is there. Nothing is there. No.
Now it is.
Now it is visible.
Now it is visible, sir.
Now it is visible, huh? Okay,
Now it is
fine.
visible, sir.
Okay, now we'll continue with this. Okay, now read the question. Read the question carefully and look at the diagram also. So same thing, like what you should do. Initial and final situations is what you should. Yeah. He's telling the system is in equilibrium, the string joining C and D. Now I'm going to cut the green color string. There are three strings are there. So here, black color string one, string and spring. So try to, I think, notice the difference here. There's a one string. Black color string is one, which is passing over a pulley. Red color one, connecting between the blocks B and C, and between from the block C to the ground. So now the string joining C and D is cut. Just after string is cut, so we have to work out all the things. Okay, first let's not bother cutting. So before cutting, what is the state of this? Is the system is in equilibrium. So show all the forces acting now. So this will be the 3 mg force. Mg, and here is the spring force kx. This kx should act here, no? So here, if you want for the spring, you show like this, kx, and on the pulley also you can show like this. Here also you have to show one, and so many things. No, the space is not there. I'm just showing it to this one. So here, that is kx. It will be here. Then the weight mg, tension T, or T1 you write it, no problem. And here the weight mg, T2, and this is T2. I think I'll magnify it. Okay, fine. All things things are visible clearly for you. Check it now. Okay, let's write all the equations. Then I'll come to the later part. What should be the kx equal to? 3 mg only. The system is in equilibrium. Kx is equal to 3 mg. Then kx equal to here. Kx equal to mg plus t1. Kx is equal to how much? 3 mg, and this is mg plus t1. So therefore t1 equal to 2 mg. Let's keep all this one. So now t1 minus mg minus t2 equals 0. So this will be 2 mg minus mg t2. So t2 is equal to how much? Mg. Okay, let's keep the data this one. Okay, now the initial. Okay, the string D is cut. Now green color string is cut. Then what will happen? We have to analyze here. And there is no block, only spring is there. Just small observation, nothing big.
Sir, sir,
Ah,
sir, how did you get T1 equals to 2 mg?
3 mg minus mg equal to T1, no? From here, subtraction.
Oh, yes, sir.
Okay, fine. Now I'm not sure what will happen to string. So anyway, time being, let me write it. There's nothing, no problem. Okay, come for this M. This particular green color string is what? I'll show like this. It got cut. And now get into the problem. Now there's a part B, this is C. There's a block C, B, and this is A. Analyze all the things one by one.
Sir,
Yeah.
tension in the string connecting VC can change suddenly, right, sir?
Sudden change in tension possible. Sudden change in spring force is not possible. Sudden from compression, elongation, compression, not possible. Okay, your tension can change. So what you should know? So we don't know what tension will be. Let it be some unknown value T. Then work out the problem. So let's come for this. Let's come for the spring here. Tell me, like, what will happen to spring? So what is the state of block ABC? They're at rest, no? So I think that this you have to remember. This is blocks ABC are at rest. Blocks A, comma B, and C are at rest. So what is the situation of now? There from the moment I cut the green color string, from inertia of rest, they'll accelerate. Agreed, all of you? I'm using word inertia of rest. From inertia from rest, they'll accelerate. So therefore, what is the state of B? B was at rest. From rest, it will accelerate. So what will happen to the displacement of B? Just after cutting the string, it will accelerate from rest means, so what is the state of B now? So you can say almost at rest. So then what will happen to this particular, I am showing that particular point. Will there be any displacement of this point? No, there won't be displacement of this point. The reason for that, the block B open will accelerate from rest, and we are asking the problem just after string is cut. So what is the displacement of point P just after string is cut? I'll write point P. Displacement of point P just after string is cut is 0. Then no change in the length of the spring. So spring force will remain same as it is. So here also the spring force, because the spring is connected to string, so that the same spring force will be here. So now what will happen to block A? What is the state of block A? Will be at rest, no? At rest means acceleration will be 0. At that instant, so what happens? The acceleration is 0. So therefore, the very first condition, the acceleration of block A will be 0. Then what is the spring force? So first, let's come for one by one. The first part of the thing is kx minus 3 mg equals 0. So what is the spring force? 3 mg. Second one, what is the acceleration of block? Acceleration of blocks is asking. The acceleration of block A must be 0, because what is the net force acting on it? This one. Okay, let's come for B and C. What to do here? The weight will act.
Sir,
Okay.
so it is 0 for only that instant, right?
Yeah, I think again I'm making clear just after string is cut. Read the question. Just after string is cut. We are discussing the entire numerical just after string is cut. We don't know what will happen after some time. It'll be very complicated. First, try to understand all of you just after the moment string is cut, then we are discussing problem. We are not after some interval of time. Okay, acceleration of block is 0. What to do with here now? Anybody? Tension will change or not? As the tension, some other value. Let's assume T.
Sir,
Yeah.
will the blocks B and C also be at rest, sir?
That we have to, what is the, look at this T1. Earlier tension was balancing mg and T2. Look at block C. Say you have to come with an order. T1 was balancing mg and T2. Now suddenly when this string is cut, so what's happened to this tension? Will change or will be as it is? It will change. Say you may not accept all this. You have a thread, cotton thread will be there in your home. 2-3 blocks or 2-3 rocks will be there. Cut suddenly and check it. What conditions will arise? You can really experiment all these things. No, nothing big here. So now let's come for this. T1 was equal to mg plus T2. So when I cut this string, green color string, so anything will happen to tension as tension will change. If tension changes, then definitely what happen, the force acting on the block B and C are different now. If the tension earlier it was T1, now it will have some other value T. So they will have acceleration. Tell me like, so no, you may not accept. So like how you were discussing all this. You do one thing, take this B and C as one system. Earlier, the spring force, what all it was balancing. Earlier spring force, what was balancing. This T1 will become internal, no? Plus T1 minus T1. The spring force was balancing what? This mg and this T2. Agreed all of you? Now, the moment I cut this string here, then what happened? The kx, can it balance 2 mg? Earlier kx was balancing 3 mg. Now kx, can it balance 2 mg? Look at, come for here. Earlier kx was balancing 3 mg. Now kx, can it balance 2 mg? No, it's not, it cannot balance, no. So what will happen? Net force on the combined system B and C, in what direction? Upward, no? So what do you expect block B and C? Will accelerate. So what direction? Upward. So here, the acceleration of block. Will they have same acceleration? Next question. They're connected by common string. So they must have same acceleration. I'll put acceleration A. This we have to calculate. Got the idea? How to analyze? How to analyze? You come for, you have to look at this diagram. The kx was balancing mg T2. This will become internal. So kx was balancing 2mg plus T2 and T2 was equal to mg. So kx was balancing earlier 3mg. Now kx, can it balance 2mg? No. Kx is greater than kx is 3mg. No. How much of vertical downward force? Mg and mg. Sir, what about tension? Plus T minus T will cancel out. So what is the net resultant force on the combined system BC upward? So therefore the system will accelerate. Okay, let's calculate the things. So here acceleration is equal to kx minus mg plus mg by 2m. How I'm writing this equation? I'm treating the block B and C as one combined system. What is the value of kx? Kx was 3 mg. This is 2 mg. This is 2m. G by 2. Okay, now come for tension. So can we calculate how much of tension is acting? T minus. So here, what is the basic idea? The blocks B and C are treated as one system. I'll write that comment also, so that will be easy for you. Blocks B and C as one system. Is that okay? Fine. Okay, let's go for tension now. So what about the T minus T minus mg equal to ma? This is on block C. So what is the value of acceleration? G by 2. So how much of tension? 3 mg by 2. Tension will change. S. Sudden change in tension possible. S. This numerical is telling you no. Sudden change in spring force. Suddenly from elongation, compression to elongation, not possible. So here, what is the biggest problem with the student is like, you have to stick on to the basics here. The inertia of rest, inertia of motion, just after string is cut. That one, which is internal, which is external. So that you have to make it problem to problem, things will be different. So you have to analyze. There's a second problem, little bit you got some idea. Okay, what actually happens here. Shall I go for next one?
Sir, what will happen if the string connecting the ceiling and the pulley is cut, sir?
I'll give the questions. I'll give questions. I have all the cases. Okay, that one, no? So you want that? I'll bring it here. Okay, you asked question, I brought it. Read the question now. So here I think the diagram, 3 identical balls, each of mass m. I think we have to draw the diagram. Here, these are the 3 blocks, the 3 particles are there, A, B, C. These are the springs. Just show spring like this. You need to draw like in the diagram, no? The similar thing is what I'm showing it here. So all they are having same mass m, mass is same. Now which part of the string is cut? This string is what is going to cut it. So here is what the string is there. This string is what is going to cut it. Three identical balls, A, B, C, each of mass m connected by 3 identical springs when placed on a frictionless horizontal floor, occupy corners of.
Bottom also there is a spring between 2 M and
3 identical balls, A, B, C, each of mass m connected by 3 identical springs when placed on frictionless horizontal floor, occupy corners of equilateral angulation. This assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. I think correct, no?
Sir, between
So
B
there'll
and
be
C,
a
there is
string.
one more spring, sir.
B and
There's
C.
a string
Oh,
between B and C.
that one. Okay, it is actually. Yeah, I was. There's a problem with the. Okay, no. So he's telling first initially they were placed, then they were suspended. All just after string is cut only we calculated previous problem. Just after string is cut, we are discussing entire our discussion is just after string is cut. Okay, there's a thing, no? So let's write the equation. All three are identical. The springs are identical. Okay, now first, what are the forces? The weight mg. Let's come to the options. So we'll see what will happen to options first. We'll see the later options here. So these are the initial diagram. So they are in equilibrium. So here's some tension T is acting. Let it be here. Now, what is the state of springs? Earlier it was vertical, no? So now we have springs in a plane. It's there in Pathfinder, something very good problem. What is the state of springs? Elongated, compressed.
So natural length.
Oh no, read once question. This assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. So now it is suspended. Got this? So the moment you suspend, what will occur? That also we have to analyze. Then
Sir.
I'm going to cut the string. Yeah.
Sir.
Yeah.
Sir, the spring between B and C will get compressed, right?
Yeah, that's what I'm asking. So it will be compressed. Spring between B and C will be compressed. What about the springs AB and AC?
So they will
Elongated.
They'll be elongated. Okay,
They'll
now,
remain.
okay, let's, so here I'll show the spring forces here like this. So this will be the compressed, the compression, let it be kx2. And this is being elongated. So elongation, I think we show like this, no? And it's a equilateral triangle. So it's telling everything that one. Okay, let's after getting this much of information. What is the thing that one is telling? Connected by three identical springs when placed on a frictionless horizontal floor occupy corners of equilateral triangle as shown in figure. This assembly is suspended. Now, so what I should write the angle between AB, BC. So there's one more troublesome. It should be 60 degrees. The way the question is asked, no, based on that I'm writing it. So you should not blame me. This will be 30 degrees. So why you are drawing like this? Because the question himself, the information given, I assumed that information I'm showing it.
Yeah.
Fine. Yeah.
Sir,
Sir, after it is suspended, the lengths of the sides will change, right?
Yeah.
Yes,
No,
sir.
no. Look at.
Sir, he gave that.
Sir, if they won't change, then how will the tensions, the spring forces balance mg, sir?
Yeah, that's what the question. When you
Sir, the setup was initially kept on a horizontal surface when it assumed an equilateral shape, sir.
now what will happen?
Gravity acts.
Now what happen? We have to assume it to be an equilateral only. That's what the diagram itself he has given.
Sir?
Yeah.
Sir, if we assume it to be equilateral triangle, then how can we tell that they are elongated and compressed when their lengths don't change?
So can't it be possible?
Sir, if all three lengths increase, then the force on one of the masses m2 will be in the horizontal direction.
No, nothing. So here you say it's in equilibrium is telling. So one more thing, try to justify the word equilibrium. Nobody is bothered about the terms. Nobody bothered about the terms. It's in equilibrium. Now I'm going to cut the string. So it should be equilibrium only, and this will be equilateral triangle only. The way the question asked, everything, the conditions given, it should be like this. Okay, now get all the things. So this is compressed. These two springs AB and BC are elongated. BC is compressed. Then only equilibrium is possible. The main purpose is this angle, that one. So you can read the question. Corners of as shown in figure. This assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. What can you predict regarding acceleration of these balls immediately after the thread is cut? So it's telling that arrangement is kept as it is, and he is seeing that the angle will be 60 degree only. That's what he mean to say there. I understood like this. I don't know how you understood, but I understood like this. Okay, now let's assume that, okay, there's a 60 degree. Okay, I'm going to cut it. Before cutting, I think we should get all the forces acting. How to get the forces? So who will balance the weight? Either look at the ball B and C. Kx1 cos 60 degree. This one. So
Sir,
this
sin
will be
60, sir.
Sin 60, yeah. So this will be root 3 by 2 equal to mg. So keep it value kx1 equal to 2 mg by root 3. Later it may help us. And then what about kx2 along x-axis? Kx1 cos 60 minus kx2 equal to 0. K get cancelled, so this will be x1 by 2, or kx1 directly the value substitute 2 mg by root 3. This will be 1 by 2. So kx2 equal to mg by root 3.
Sir, in the first equation, why did you write equal to 0?
So that is minus some.
Okay, sir.
Okay, these are the initial values. Okay, now I'm going to cut the string. So let's see what will happen. This was the string. There should not be. Yeah. As usual, weight mg. This is a block. B. This is C. This is A. Yeah. Sudden change in spring force. Anything can happen.
No, sir.
So what shall I do now? The spring forces which were there acting, no? So I should show them as it is. Huh? This was the kx1. Then this particular kx2. I think directly from this only you can tell it, no? Tell me what will happen to block B and C.
Remain at rest.
They'll remain at rest. They'll remain at rest.
Sir, they might move in the
Sir, won't they move downward?
Say their accelerations are vanishing small.
Sir,
Huh.
sir, they might move in a horizontal plane, sir, because of a component of force.
Look at clearly. Look at.
Sir,
kx1 cos 60 will balance kx2.
Sir, but A will be moving downwards as well. Then kx1 will, force will increase, right?
What was our question, Pa? What was our question? Read once.
Yes, sir. Okay, sir.
Immediately after the thread is cut.
Yes,
Yes, sir. They are vanishing.
Just after thread is cut, no?
yes, sir. Okay, sir.
No, always stick on to that word just after, because that is what it is deciding the total course of the problem. Huh? Nothing wrong, because that the word is having lot of weightage, that we have to be careful. Now BNC will be a test.
Yes, sir.
Now what should happen to
Sir,
Sir, 3G, sir. A will move with 3G.
Yes,
Sir,
sir, 3G.
sir, shouldn't x1 be equal to x2 because it's an equilateral triangle?
what is this new ideas? Why the mathematics you are bringing here?
Sir, you draw all three angles 60, right, sir? So equilateral triangle.
Don't you see this equation? Why you are bringing mathematics here? Don't you see this equation? Whatever you want, you cannot think. There should be some meaningful thinking at least.
Sir, x1 equals to x2 no, sir, because they are of same length.
Oh, I don't know, Pa. Like I can't explain anything further the way you are thinking. Look at this mathematics. Is this wrong? I shaded blue color.
Sir, what wrong did I do, sir?
What wrong? The assumption itself is wrong. The idea itself is wrong. So you can't just imagine whatever you want and you say that will be correct. So what is the state of this spring? This is compressed. These two are elongated. Look at the forces acting. Look at the system. At least looking at the system, you are not supposed to think here. Or at least after bringing mathematics also, still you are thinking means something, equilateral triangle. So therefore they should be equal. Springs are already equilateral triangle. So is there any rule that like that it was made?
Sir, it's an equilateral triangle. So the length of the spring plus the elongation should be equal, right?
We have one mathematics here. Check it now. Here there are two springs are there. Here only one spring is there. Okay, fine.
Yes, sir.
So I think just enough information I put on this. That has to be first analyzed properly. Without analyzing, say you can think arbitrarily, whatever you want, you can think it here. But it should be something related to some problem, no? The thinking. Okay, now BNC will be a test. The conclusion I'm making it now. AB equal to AC equal to 0. Next again, come for these two. Or say like if you are really getting confusion, let's start the problem from here only. So no, so like we could not understand. Leave this. I'm starting the question from here. Okay, fine. Now no problem. Let's assume this is a system. It's in equilibrium. I'm going to cut the string. I'm asking you the acceleration. Fine. If you're really troubled so much, no. So let's start from this diagram one. The diagram itself I'm giving you. Okay, this is a condition. I'll cut the string. I'm asking you now acceleration. Now come for diagram 2. What should be the acceleration of block A now? Acceleration of B and C what will be equal to 0. What about the acceleration of A? Acceleration of A should be equal to mg plus 2kx1 cos 30 by m. G plus this will be 2kx1 value of this will substitute all 2 by m. Kx1 is how much? 2mg by root 3 cos 30 is root 3 by 2. So this will become g plus 2g 3g. Yes, it's possible. vanishingly small. Vanishingly small means almost equal to 0. The interpretation you have to do like this here. Directly, you do one thing. So most of you are unable to understand the situation itself. So let the diagram be this one. I am giving that this is a situation. Okay, now I'm going to cut the string. Tell me what will happen. Fine. Okay, now come for this. There's a one, the best problem what you are having. Here things are very easier. Just analyze this once. The system shown in figure is in equilibrium. The blocks A, comma, B and C are of equal masses. The face is frictionless. The pulleys are light and friction. The thread is light and inextensible. The springs are light and the block B and C are connected to the axles of the respective pulleys by rigid links. Find acceleration of the blocks A, B, C immediately after. Thread is cut at point P. Next, the spring S is cut. I'm introducing now a situation where the spring is cut. Till now only string is cut, no? The spring is cut. So let me draw the diagram. Meanwhile, you try it. I'll finish off the diagram. They're same mass, no? So here we don't know the blocks in or of equal masses. Yeah. So this is spring. This is like a rod you can treat. It's telling by rigid links. Are you try to notice that rigid links means not like a string. This is some sort of like a rod. Okay, this much information we have. Okay, it's not giving anything. So something further we have to work out here. So these are the pulleys. Huh? Let me show pulleys. So I think before entering into the problem, what is the initial? It's in equilibrium. So let's search all the forces that are acting. What are all the various forces that are acting? So these are the block A. He has not given angle of inclination. What to do? Springs are light and and massless telling, and block B. Let's find the acceleration of block A, B, C immediately after this. Angle of inclination is needed, no? Yeah.
We can take some theta, sir. In the end, if it might be independent of theta also.
Okay, I'll assume theta. Let's see that, and will further will it help or not? I'll just assume some theta. I think I'll draw a little bit below. Block is there, no? Okay, carry on. Now get the all the things. So let this be theta. This is a fixed no, it will not move. Let's start one by one. This will be mg sine theta. No. What can be spring? Elongated, compressed. So what do you suggest here?
Elongated.
Will be elongated.
Elongated.
It must be elongated. It must be elongated. Kx1, I'll write it. Or x2, anything, because two springs are there. No, let me call kx1. The system is in equilibrium is telling pulleys are light, the thread is light in nature, the springs are light, and the block B, C are connected to axles of respective pulley by the acceleration of block. So kx1, I'll write it. So here the same spring force should act here. The same spring force is what here to show it. So here kx1, this will be kx1. Then here, this is mg. So what all the other forces that are acting, that become internal. The pulley and this link no will become internal. So there's the condition. Okay, now with this, can you say anything about 2kx1 equal to mg, no? So from
So sin theta 1 by
2kx1 minus mg equal to 0. So kx1 equal to mg by 2. This is for pulley P1, I'll write it. Pulley P19, P2. So here what happened? At pulley P19, block B. Okay, got it now? So from there, I searched it, I got this much here. Okay, keep it here. Now for block A, kx1 minus mg sine theta equal to 0. This is for block A. Kx1 equal to how much? Mg by 2 from the above equation. So theta I'm getting
30 degrees.
30 degrees. Okay, now fine. Let's come for this. So kx1. So here what are this will be mg. So the same spring force should act here again. Kx1 and this will be kx1. So here I'm not sure anything what is the spring force. So let it be, it didn't say anything. The springs are light and the block B and C are connected. It didn't say anything about the springs. Are they same or different? So what shall we do here? Anybody? It didn't say anything. There's no information about the spring. The pulleys are light and friction. The thread is light and initial. The springs are light and the block. So the springs are telling the springs are light means so the same identical condition. So let me assume K only.
Sir, can you repeat why, sir?
The springs are light and the block B ends are connected to axles of the respective pulleys by rigid links. The springs is telling the springs are light, so it assumed same spring constant. The question itself, he didn't say anything. Let me assume some value, both let it be same. Okay, fine. So don't blame me now. So let it be some elongation kx2. Okay, fine. I'm just assuming it to be k. We will see any difference will it make. What about kx2 from the diagram? Kx2 should be equal to 2kx1 plus mg, no? This is for what? Pulley P2 and block C. So kx2 is equal to how much? Kx1 is equal to mg by 2, or 2kx1 is mg. So this will be mg. This is 2 mg. So don't blame me. I'm just assuming some value of k. this one. So let it be. So this is the initial part. Okay, let's come for the thread is cut at point P. Where is the point P? The point P, I'm bringing it here. There's a point P and there's a point S where I'm going to cut the spring. Okay, if I cut the string at point P, what conditions will arise? What will happen to this particular string? That will become loose, no? The string will become loose. What will happen to spring force here? There's a really troublesome for students. Sir, you only said sudden change in spring force possible, but this particular say like the spring what happened got elongated, no? So where is the support for him? The other end is support here, no? The support is there. This will be, if this is cut, what happened? The string will become loose till here it's connected. So what happened to spring? Spring what happened? The spring force will vanish. Here what happened? This spring force will vanish here.
Sir, can you repeat it?
So now you look at this particular spring, no? So what actually happens here is, I think I'll help you with a diagram. If this is a thing, it is being elongated, and I'll connect this spring to another wall in this way. Let's assume this one here, this one. So now what is the state of spring? So let it be elongated. The same similar thing to make you understand I'm bringing. Now if I cut this particular string, tell me what will happen to this particular thing. The spring what happen, all this will suddenly the spring force will vanish. Because why the spring force is there? Because of this tension. Or this you'll not understand the block. I'll
Sir, it will come back to its natural length.
Yeah, that one. So what I mean to say is spring force will vanish. Okay, if it is like this, you have string and a spring like this. Now if I cut this particular string, now what will happen to it's being elongated? Why it is elongated? Because tension, I'm saying the string is taut. So therefore the spring force will act like this. So let's assume if I cut it, tell me what will happen to the spring. So what is the state of this? This particular string will be tell me what should happen to spring, anybody? The string is permitted to attain its natural length, no? All of a sudden what happens? The spring force will vanish here because there is no force to maintain that elongation. Because earlier what happened? How that elongation is maintained? Because here there was one more force is acting. What is that one more force? The reaction by the wall. So how that particular spring is in equilibrium? Because the tension T and this R. So now what will happen to spring? Spring will attain its natural length. This is earlier elongation.
Sir, the spring is attaining its natural length only because the string connected to the spring is being cut, right?
Yeah, that one. Because there is no supportive force for the spring to retain that particular length, the particular elongation.
Okay, sir.
I think this idea is very important, where most of the books what happen are missing it. That's why I just picked up from this particular thing. So let's later on we'll apply this to various concepts. So here I think I'm giving diagram like this. Fine. So what is this string now? So there's no elongation or compression. Is it similar thing happens for this particular spring? As the spring will attain natural length. So therefore I'll call this a spring P, A, B, C, S. All the symbols I use, no? P is there, P1, P2. Spring S1 I'll call it, or say like a S1. So what is the condition I should write? When the string at point P is cut, so what will happen to the spring force in spring S1 will vanish. then what will happen to the block A? It will only experience its weight, no, mg sin theta. So then what is the acceleration of block A?
G by 2.
It should be equal to g sin theta, just acceleration down the incline. See, all these questions are not something within 2 minutes here to solve. Of course, they need time. Huh? Yeah, all these are learning questions, not something for to test a student, just for learning purpose here. So first case, I'm starting the first case here. Thread is cut just after thread is cut at point P. What will happen to spring? Spring force will vanish. The spring S1 will spring force in spring S1 will vanish. Vanish in the sense attains natural length. Okay, fine. So what happened to the block A now? What is the only force acting on the block A? G. What is the mg sin theta by m? So what is the acceleration of block A now? So what shall we write? Acceleration of block A should be mg sin theta by m. G sin theta. So this should be g by 2. What is the direction? Down the incline. Is that okay? Arrow, look at this. No, the string is passing over a pulley, no? The string is passing over a pulley. This particular string is passing over a pulley. Why it is connected to spring S? Look at the diagram. This particular string is passing over a pulley and the spring is connected to the pulley P2. What should happen to block B and C?
Sir, since there is no support for B, it will go down, sir.
With G.
What happened to B and C?
C will remain at.
Sir, C is a test.
C will remain as it is.
Acceleration of block B, anything, anybody?
Sir, it will go with acceleration G downward.
Equal to
G,
G
sir.
downward, no?
Yes.
Because acceleration of B is what? mg by m. So it should be G downward. What about similarly C?
0.
Earlier, what happened? So look at this earlier. Kx2 was balancing to Kx1 plus mg. Now the spring force Kx1 got vanished, no? So what are the forces that will be acting on the block C now? Block C, the pulley and block C you take together. So what force I have to show it? I think I have to draw a diagram. Huh? Nobody will understand if I just speak it.
Sir, will it accelerate upwards, sir?
Yeah, that's what I'm telling. So this is the spring. Okay, now here that spring force will remain as it is, no? So this is the string. Okay, all of you try to see the diagram. I'm some way I'm trying to help you. So what happened? The string has become loose, no? So this will be what are the only forces acting on this system now? 2kx2 minus mg. So together with the pulley P2, the block what happened will experience a force 2kx2 minus mg. So what is the acceleration of C? Should be equal to 2kx2 minus mg by m. What is the 2kx2 value is how much?
Sir, 2k extra is 2 mg, sir.
Okay, this one. I think kx2, sorry. Kx2 value is how much? 2 mg. So this should be equal to g upward. So therefore acceleration of C will be fine. So these are our answers. Huh?
Sir,
Ah.
so just a small doubt, sir. In the right side, starting supportive diagram for spring, sir. Can you cut?
Here. So the string it is passing over a pulley and the spring is connected to pulley.
That spring.
That spring is connected to pulley
Yes, sir.
here. Not connected to string. It will be connected to pulley like this.
Yes, sir. In that supportive diagram for the spring S1, sir, there will be a normal reaction by the wall also, right, sir?
No, that will become everything internal. No, it's a rigid link that will become internal. All that forces acting on the pulley and block, you take one system. So what all force that acting between the pulley and the block will become internal. We need not to bother. That everything will become equal and opposite. Am I right?
Yes, sir.
I just made problems simple. Huh? So if you want, you can show forces, but that will become internal. So need not to bother, no? Because he's telling this is not a string, rigid link. Am I right?
Yes, sir.
So the forces acting in this will be equal and opposite. Finish all. I'm making pulley block as one system. So what force acting now in this rod, no, that will become internal force for the pulley for P2, this one here. So what is this equation I wrote for the total? This is for both for pulley P2 and block. So this is what will happen even for acceleration of okay, is that okay? I think I'm helping you this much. At least okay now, fine.
Sir, but what about in the spring S1, what about the normal reaction by the wall, sir, in that above diagram?
Which one? Here, huh? This particular thing, huh?
Yes, sir, you cut the string and you drew a diagram down.
Yeah, this normal reaction, huh?
Down, sir, down of that diagram.
I don't know, down of the
Sir,
diagram.
you drew a diagram.
Yeah. This one here, huh?
Yes, sir, that normal reaction by the wall.
So some because of some why normal reaction? No, string is light. Finish or no, nothing will be there.
Sir, for the spring.
For the spring also, nothing will be there because no spring force, because no force is acting. This R also will vanish. This R will vanish.
Okay, sir.
Yeah. Okay, now I think we have completed half part of the problem. Huh? And now the spring S is cut. Now, is it justified to write K only or can I take any value? Because I think I assumed it. This what we assumed it. I'll write it clearly. He didn't give. Shall I assume some K dash? Will answer will be same? I think students really should answer this.
Yes, sir.
Because it doesn't matter, no? So therefore I assumed it. So I think you should not blame me, huh? Because initially somewhere telling sir to get answer you are writing. No, if I write 2K or K dash, it doesn't matter. Am I right? Even if I write K dash also, I'll get same answer. So I just assume that
Only
at S what happened, the spring constant didn't give, intentionally didn't give. So we can assume any value, we can continue, we'll get the same answer. No, the spring S is cut. I'm going to cut the spring itself.
Sir, is S on the spring or is it on the string connected to the spring, sir?
S is the point on a spring, no?
Okay. Okay, sir.
Okay, I'll get the diagram. So there's a block. There's a pulley. If you want, you can call them as rod. These are some rigid link is telling. So this particular thing will be rod. Okay, this will be a rod. Hmm? Okay, there's a diagram. I'm continuing here. This is theta, what we earlier assumed it. Okay. Now what I'm going to do is like this particular spring, I'm going to cut it. Tell me what will happen. I'll just show like this, so that it'll be easy for you. So it justified that the spring is being cut. Okay, now try to analyze the problem. These are the pulleys. It's a good problem for really, like I would have been felt happy if students on their own, they would have thought such challenging problems. But nowadays students, they don't have patience. The moment they see question, they want answer. So that learning ability of students got decreased like anything. You should blame the education system in India. The competitive exam, you have to blame that one. Because the overall things what when they don't permit you to really learn. You can blame even teacher also. Because yesterday I gave how many, some 30 questions and I asked you to come on, give the answers for this. So there'll be wrong thing, no? When spring S is cut. So the second part of the problem, when spring S is cut. Yeah, can get into the problem now. What will happen to spring force? Directly spring force will vanish, finish over. The spring force, the kx, what were the spring force that was acting here, no? kx2 was acting, no? So the spring force kx2 vanishes. So here I'll write it, no spring force. Now what will happen to the other part? What will happen to this spring? What will happen to this tension? So that the weight will act, the weight mg will be acting. Here this weight mg will be acting as usual, and this mg sin theta. Yes, anybody answers? So what happened to this spring force? Spring force kx2 vanishes, or kx2 is equal to 0. Now this one, anybody? What shall I do with this particular string? This was the point P, no? Yeah, I'm telling this one. What will happen to any impact on this and the spring force?
Sir, there is no impact on the other spring, sir.
Sir, thread will become loose.
Just after the spring is cut, there won't be any impact, so, but eventually the thread will become loose.
So this spring force, nothing will happen, no?
No.
Because so the spring force as usual, I'll show it. Kx1. So here what force? Kx1. This will be Kx1. No, this much will be there. Huh? So now there is no change in the force acting on the block A. Am I right? So net force on the block A is 0, no? So shall we write first equation? Now what about the force acting on the block B? Earlier to the pulley and the block B, you treat as one system. This rod you need not to, the forces acting in the rod will become internal. Okay, all of you? I'm making things clear. So what is the net force on the pulley P1 and block B? Will remain same as it is, no change. So therefore acceleration of pulley P1, acceleration of block B 0. I'm making things clear like this. Let's come for block C. Earlier what happened, the Kx2 was acting, Kx2 was balancing Kx1 and mg, no? Now that balancing force Kx2 is not there. So what is the net force on the pulley and the block C? Pulley P2 and block C is downward, no? And the force acting in the rod will become internal. So here, if I show one more diagram, spring force, there's no anything called like a spring here. So this is what I'm showing. At least all of you looking at this diagram, you should able to understand what I wanted to explain here. Rather than speaking blindly, no, I'm giving enough of proof for you. Pulley is light. So what is this? Everything will become one system, no? And what is this? This is a rod. It should not be a string. If the string, there's a big problem will arise. This must be a light rod. Now, what is the net force acting on the pulley P2 and the block C? Spring force and the weight. So therefore, what is the acceleration? AC should be equal to 2k x1 plus mg by m. What is kx1 value? Should be equal to mg by 2, as we know already. Total acceleration of block C should be equal to how much finally?
2g.
2G, sir.
2g, it should be downward. So what are our answers? Acceleration of pulley P2 or this one? Both are same.
Sir?
Ah.
So the acceleration of block C is due to the loss of spring force only, no, sir?
Yes, yeah.
Okay, sir.
Sir, what happens if it's not a rod and if it's a string, sir? What problem?
Then tensions, what happen? Impulse will come, a lot of complications will come. Then we can't conclude the problem.
So what did you say, sir?
Impulse, if you don't know impulse, so I can't explain impulse one chapter itself.
What was the question?
Whose question? You don't bother? You don't bother? Because if the string, what happen, the impulse impact will be there. Again, it'll be very complicated. Huh? That's why what happen is showing that is nullifying things. Huh?
Okay, sir.
That's okay. This is what I think. Okay, yeah. The second part. Okay, it's visible. Completed this. One more last one more within 10 minutes. It's a very small one. Where we'll wind up this. Or shall I continue tomorrow? It's left to you. Choice is yours. If you have patience enough, I'll continue. Orders tomorrow. Tomorrow, okay? Yeah, fine.
Sir, continue, sir.
Sir, continue, sir.
Continue. Okay, then those who want tomorrow, okay, just you can leave the classroom, no problem. Okay, I'll finish off this very small one. Huh? Don't get scared. So many blocks are there. The system is in equilibrium. He has given one condition, you see, M1 plus M2 greater than M3 plus M4. The string at point P is cut. Here is the point P. Find the acceleration of blocks just after string is cut at point P. I think better what happened before cutting, what are the forces acting on the blocks, everything. Better let's have a diagram. So if I have a diagram, no, then we can do something. Okay, let's go for diagram first. The weight M2G, the masses. So here the weight M2G, or we can show individual. So rather than this, I'll try it here only. This will be M2G. So here the elongation in the spring, so let it be Kx1. This is mg. Here the tension T. So the weight M3G will act. This particular string. So let me assume it got elongated. So spring force Kx2. Here Kx2. Then this is mg. M4G. And the tension this string, let it be say some T naught something, I'll write it. Anyway, because we are going to cut it, no problem. Initially fine, this much. So Kx1, is it equal to M2G? Yes, it is, because all they are in equilibrium. The blocks are, the system is in equilibrium. So because of that, I can equate the net force acting on individual block here. So first Kx1 minus M1G equal to 0. Keep it here. And then this tension acting, so how much of tension should be known? The tension T minus M1G minus Kx1 equal to 0. This is M2. Okay, keep it here, no? This is M1G, M2G. So what is the value of tension? M1 plus M2 into G. Okay, you can treat that everything as an equilibrium or internal. That is all this force, this Kx2, what all acting will become internal. Directly this tension, what all it balance, M3G plus M4 plus T naught. So I'm directly going for it. So let's calculate again the same value, T, or I'll write individually. Okay, then no problem. Then on the block M4, what is the value of T? No, we know M1 plus. So we have spring force value. Kx2 is equal to how much? M1 plus M2 minus M3 G. So it may help. No, can we calculate the tension T naught? Yes, by equating forces now. Kx2 minus T naught minus M4G. Kx2 is equal to how much it is? Now M1 plus M2 minus M3. So T naught should be equal to M1 plus M2G minus. So the difference in the mass of the system on the left and right hand side is what? The difference in weight of the blocks is what? On the left hand side to right hand side is what? The tension T naught. I agree this. So, and anyway, it's given, no? M1 plus M2 greater than M3 plus M4 justified. So what is the state of this green color string will be taut. So what is the state of that green color string? It will be tout. T naught is there. Now I'm going to cut it. So if I cut, then what conditions will arise? So the moment I cut at the string at point P, what happened to tension? Will vanish, no? That T naught will vanish. Then we'll see what all will happen here. I'll draw the diagram after cutting it. This is M1. Oh, I'll go for next page. Huh? Let me see. We can adjust here only. Oh. Yeah, fine. Okay, now we have diagram. I'm going to cut the string. So don't get scared that one. So come by don't be in hurry. So there's such numericals happen really, even for teacher also. If I just do in hurry, no. So definitely I'll miss any one force and I may give wrong answer. So with patience, what happen, you have to analyze each and everything. Come by each one, each on each block, what circumstance will occur. Then what happen, you can conclude it. Here is what that string which I have cut it. No, I think the weight of the blocks will continue to act. There won't be problem with the weight of the blocks. Now, what should happen to the spring force? Kx1. Will it change or remain same or changes? The spring force Kx1 will change only when M1 or M2 will undergo displacement. So what is the state of M1 and M2? They were at rest. So the moment you cut the string open, that inertia of rest, they'll be in the state of rest, no? So due to inertia of rest, what happen? The displacement of M1, M2 will be 0. After some interval of time, they'll start moving. So what is the state of M1 and M2? They'll be at rest. Got this idea? This will be, but sir, this tension can change. Why you're not thinking in that way? Okay, let's do one thing. If I cut this string, so what will happen to first this spring force here? So this will be as it is, no change in that, Kx2. So the spring force will not change means, look at the block M3. If the spring force changes, then only the block M3 will undergo displacement.
It will be.
So it will be also at rest. So this will inertia of rest. Better I should not say rest here, inertia of rest here. It will retain state of rest at that instant. So therefore now M1, M2, M3, they'll be at rest, no? Or acceleration, better say 0. Instead of calling, say acceleration 0. So no change in spring force. So spring force will be Kx1, Kx1. So what is A1? A10, A20, A30. So what is about only A4? No. So what do you expect the block M4? In what direction it will move? Up or down? It should move up. Then what is the equation for that? A4 should be equal to kx2 minus M4G by M4. Do we know kx2 value? Yes, that's what the thing we brought it, no? M1 plus M3 minus M1 plus M2 minus M3G. So what is the value of A4? Should be equal to M1 plus M2 minus M3 G minus M4G by M4. This will be the acceleration, and what about this acceleration will be directed vertically up. I'm just showing in the diagram. Okay, now many blocks, many springs are there, don't get scared. And the tension, let me show as it is, no change in that. So that word I'm bringing, it will accelerate from rest. So therefore, that's why the acceleration of block 1, 2, 3 will be 0. Any doubt in this? You can clarify. Okay, no, shall we end of the class?
Yes, sir.
Okay,
Okay.
yeah, thank you for
Thank
your
you, sir.
patience.
Thank
Thank
you,
you
sir.
for
Thank you, sir.
thank you for your patience hearing.
Thank you, sir.
Great, sir.
Thank you, sir.
Thank you,
Okay,
sir.
okay.
Thank you, sir. Bye, sir.
Okay, thank you all of you. Take care. Bye. See you. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.